Do you want me to go back again, or like, start from here?
Yes, I
Because,
was listening, so I don't have any problem with
okay, very quickly, right? Because I'm recording,
that.
so otherwise, like, okay. So we are maximizing over consumption and leisure, right? And we are representing by indifference curve over the two commodities. Like one is composite consumption Y, and the other is leisure L. But composite consumption Y is basically like my income, and income is like the wage rate, the market wage rate times the hours of work. Since there is no saving, Y is exactly equal to my income. So basically this optimization process is going to give me optimal number of hours and optimal number of leisure hours. Okay, so an indifference curve is a curve that joins all indifferent points, right? The combinations of consumption and leisure that gives the same amount of satisfaction or utility. And higher indifference curves reflects higher level of satisfaction. So whenever you're maximizing utility, you want to reach the highest possible indifference curves, right? So that basically in this Y and L plane, you want to reach the highest possible indifference curve because that will give you the highest level of happiness. But the problem is you are faced with constraint. So it's not an unconstrained maximization. You will face constraint. But before going into the optimization, I just want to touch on the properties of indifference curve. We can see that the indifference curve is downward sloping, which means that there is a trade-off, right? If you want to have more leisure, you have to sacrifice consumption. If you want more consumption, you have to sacrifice leisure. And you can see that the rate at which the consumer is going to trade off between these two Y and L depends on at what point the individual is at. So you're on the steeper part of the indifference curve. You can see that you are willing to, this individual is willing to sacrifice a lot of consumption in favor of a little bit of leisure. When you are at the flatter part of the indifference curve, you can see that you are willing to sacrifice a lot of leisure for a little rise in consumption, right? So basically the trade-off depends on what position you are in, like at what location of the indifference curve you are at currently. Okay, indifference curves are downward sloping, and the slope of the indifference curve is called the marginal rate of substitution, which is basically you are substituting between consumption and leisure. The rate at which you are going to substitute depends on where you are. So if you are over here, the slope is very steep. When you are at the flatter part of the indifference curve, the slope is flat. That means like, you're willing to sacrifice a lot of leisure for a little bit of consumption. Okay, so this is very basic stuff. We already covered it. That's why I'm going a little bit quickly. And then we talked about two constraints. One is a time constraint and the other is a good constraint. Time constraint T is my hours of work and my leisure hours. If you add them together, that gives my total um, hour that is available. So if you can think of this as 365 days, or you can think of this as 24 hours. So T is basically the nature given time of maximum time that is um, available or feasible, and we are going to divide it between hours of work and leisure. Okay, so leisure basically captures your leisure hours, your resting period, your recreation, your consumption, everything else. So we are just basically dividing our hours of available hours into hours of work and everything else lumped into leisure. So these two added together gives you the available time or the total time available. All right, and then we have a goods constraint, which is basically saying that whatever income I have, so if I work 8 hours in the market at a wage rate W, my total income is going to be W into 8. And the composite price of the composite commodity is a price index, so it's a composite commodity is the value of the composite commodity is going to be price into the commodity, which is these two are vectors, right? There's a price vector and commodity basket. So the total expenditure, right? I'm spending for each Y, like whatever, rice, flour, sugar, whatever we have in this basket, and we multiply by the respective prices. So we will have the total expenditure that has to be equal to my total income. So that means that my total spending is exactly equal to my total earning, um, implying there is no saving, there is no borrowing. We are completely ignoring those, right? We can have multi-period, like, situation. We can borrow from future, or we can save and consume in future. But, like, it doesn't change the intuition of the model if you introduce more complex model. So the two constraints are number one and number two. And so what we are going to do is we are going to, like, substitute h is equal to t minus l into equation 2. So, and then you manipulate, and then what you have is w2 in equation 3, you have wt equal to py plus wl. So this is basically called the full income constraint. What it means is that my total available hours in a day, or in a year, or in a week is t, and if you multiply it by w, that is the total feasible income. So if you have zero leisure, you work like 24 hours a day, that is the maximum income you can have, the total full income that is possible. And that we are going to divide into the expenditure, right? Part of my full income is actually the earned income, that means I work, and the rest is the opportunity cost of my leisure. So if I spend 10 hours of time out of 24 hours, like, if I spend 10 hours in leisure time, what is the opportunity cost of my leisure time? Each hour of leisure at home, I'm giving up 1 hour of work, and 1 hour of work in the market is rewarded by W. So my 10 hour of leisure is basically I'm giving up 10 into the wage rate. 10 W is the opportunity cost, or my cost of leisure. So these two expenditures, the cost of leisure and cost of consumption, added together should be equal to my total potential income. So this is called the full income constraint. If you manipulate the full income constraint, you can write it like this, right? WP, so if you keep, like, Y on this side and take everything to the other side and divide by P, so you will have WT by P, which is basically, you can write it by W by P into T, and then plus, which is basically, since you're moving it this way, so it's going to be negative, it's going to be WL by P, negative WL by P. So if you look at this equation, we can see that W, P, and T, these are basically parameters, right? They are constant and they are given to you. So this part is a intercept, because nothing is varying over here. If you look at this part, we have, like, minus W by P multiplied by L. So L is my variable. Okay. So this part is then the slope. So if you plot equation 3 in a graph, right? So before plotting equation 3 in a graph, let me see what, if it helps you to understand that T is equal to 24 hours, yes, you can think of T as 24 hours. T can be total number of hours in a week. It can be total number of hours in a month. It can be like 365 days, right? It can be 30 days. Whatever unit you choose, it's the, like, that it's given. You cannot have, like, more than 24 hours. You cannot have more than 365 days, or you cannot have more than 7 days a week, right? Or, like, to simplify things, you cannot have more than like 30 days. You can have 31 days, but just to make our lives easier, just you can think of it that way, right? So it's something that's given by nature. It's a constant, right? It's a parameter. All right. Before plotting the full income constraint, look at this, right? So we have composite commodity or consumption in the y-axis, and in the x-axis, we are going to plot leisure this way, rightwards, right? So we start with 0, and if we go towards the right, that's like, increasing our leisure. And we are going to measure our hours of work starting from t like, so this is maximum from 0 to t is possible. That means, like, you're having, like, if your L is equal to t, that means all of your time you're basically enjoying as leisure, you're not working at all. Your hours of work is measured from t, where at this point where it's equal to 0 and moving towards the left. Okay, so because it's obviously, like, together they have to equal to t. So L is measured this way and H is measured this way, and they are bounded by 0 to 2, this length, because you cannot go beyond T. T is a parameter. Okay. So now if we plot the full income constraint in a graph, we can see that WT by P is the vertical intercept and slope is W by P. Okay. So now tell me, right, what does the slope indicate? What does this W by P tell you? No answer? Okay, first of all, it's negative. So that means, like, if you move along this line, that means if you increase leisure, you have to give up consumption, right? So you are facing a trade-off. And if you increase leisure, that means you're reducing hours of work, because you see that they're moving in opposite direction. H and L, they are completely moving in opposite direction. So if you increase one, that means obviously you're reducing the other. If you increase labor this way, you're actually reducing hours of work. Okay. And if you increase hours, that means you're reducing leisure. All right. So that's basically, like, from this. But the slope W minus P, like, who is drawing? Can you not do this, please? Whoever is doing this. Minus W by P. So it means that, remember, W and P are both parameters. These are given to you. You cannot change them, right? So this reflects the market rate of trading between L and H, or L and Y, right? So what it means is that if you sacrifice 1 hour of leisure, right? Like, if you sacrifice 1 hour of leisure, what are you giving up? You are basically, your opportunity cost of 1 hour of leisure is W, and you're gaining, because you're increasing your hour of work by 1, so you're gaining some income and you're spending it. So basically you're gaining some amount of consumption, for each hour you're sacrificing. If you sacrifice 1 unit of consumption, then how much leisure are you gaining? That is reflected by this W by P. Since it's like, the market rate of trade-off, because this is WP are constraint. So any movement along this line, right, the full income constraint is reflecting the market rate of trading between consumption and leisure, and the rate at which you are giving up, like, switching between these two, is given by minus W by P. All right. So now if you look at the slope, like WTP by P, right, this is the vertical over here, and what is the vertical axis over here? Can someone tell me? When y is equal to 0, go back to this equation, right? When y is equal to 0, then what do you have? L is equal to
W by PL equal to W by PT. That means L equal to
equal to
T.
T. Very good. So it means L equal to T, right? So that means we have T. So if you divide W by T by P into T, all you are left with W by P, right? So this is basically what the slope is, right? It shows that if you sacrifice this amount of consumption, the whole amount of consumption, you will gain this amount of leisure, right? And then, like, so sacrificing this amount of consumption means you'll gain W by P amount of leisure. Do you get it? How do you calculate slope? Rise over run, right? So what is your rise? WT by P. What is your run? T. So your slope is WT by P divided by T is W by P. So if you sacrifice this amount of, like, this amount of consumption, you will gain W by P amount of leisure. Okay, clear? So that's basically what this budget constraint is. So what we are now going to do is we are going to bring the two curves together, my indifference curve and my full income constraint. So my objective is to stay on my budget full income constraint, but reach the highest possible indifference curve, right? I want to make myself as happy as possible and choose my consumption and my leisure optimally. Okay, so to find that particular combination of consumption and leisure that makes me as happy as possible, that makes me reach the highest possible indifference curve but still stay in my full income constraint, and that is achieved at the tangency point. So wherever my the indifference curve, one of the indifference curve is tangent to the full income constraint, that particular point reflecting the optimal consumption and optimal labor and leisure, that is maximizing my happiness, right? U double prime, like is a higher indifference curve. Like every consumer would be happy to be on the higher indifference curve, but the problem is, given your budget constraint or given your full income constraint, you cannot reach that level of utility. Okay, the U0, the other indifference curve, which is below the U prime indifference curve. So this is feasible. But the problem is, you want to be on the highest possible indifference curve. So this intersection point, this point or this point is not optimal because it is possible to reach a higher indifference curve. So these are not optimal points. And the other problem with these points is that the optimal condition is reflected by the equal slope, because this indifference curve is tangent to the full income constraint. So it means that the slope of the indifference curve is exactly equal to the slope of the full income constraint. And the slope of the full income constraint is what? Minus W by P. And the slope of the indifference curve at this point is what? Delta Y by delta L, right? So we can see that the slope of the indifference curve and the slope of the full income constraint will be equal at the tangency point. But at this point, at this intersection point, we can see that the slope of the indifference curve is much flatter than the slope of the full income constraint. So that means that the trade-offs are not the same. Okay, that means if you draw tangency at this point, the indifference curve, you can see that that means this individual is sacrificing a lot of leisure hours. If you let me help you by drawing. Forgive me, the drawing is not going to be very nice, right? So you can see that at this tangency point, this consumer is sacrificing so much amount of leisure for a little bit of consumption. But the market is saying that, look, you can do much better. You can sacrifice a lot less leisure to gain more consumption if you move this way, right? So basically, this point is not optimal because the consumer can make his or her situation better by moving along the full income constraint. And at this point, at the tangency point, you're reaching the optimal because this at this point the two slopes are equal, and there is no way, there is the market rate of trading, which is the slope of the full income constraint, right? W by P is constant, is exactly equal to the individual's rate of trading between leisure and consumption. So the two slopes are equal. So at the tangency point, the two slopes are equal. At any other point, the slopes are not going to be equal. That means that there is an opportunity to make improvements, right? To make the utility better. All right. So I ask you to calculate the equilibrium condition, right? And see that whether how we can prove that the slope of the indifference curve is equal to the ratio of the marginal utilities. Did you guys do it? Okay, so let me do it for you. Wait, it doesn't allow me to share this. Oh my God. What is happening? Where did my okay. There's a bug. It's not allowing me to. What is going on? Oh my god. Let me close everything, okay? Something not working. Can you guys see the whiteboard?
Yes, Professor.
Thank God. So what did we do? We are multiplying and dividing by same DU. DU means delta utility, right? So um, so we can say write this as DU by DL times DY DU by DL times
Professor, it should be divided by dy by sorry du by dy, right, Professor?
just a second. dl times du. So it should be du. No, let me just go like this. dl divided by, no, multiplied by du theta divided by dl. Times du by dl times du by du by du. So let me see if it makes any sense. So since this is the is to du by dy, du by dl into dy by du. So du cancels, dy by dl. So yeah, this is okay. All right. So now we are going to write this as one by du by dl is marginal utility with respect to leisure. Marginal with respect to, how do I write a small l? Let me just switch. How do I change the font? How do I change the font? Oops. It doesn't allow me to change entire font. It's only this one. If I just click over here, will it let me change just for one, or it will again happen? No good. Okay. Now it's acting crazy. My God. It doesn't let me go back. Anyway, so are you following me so far?
Yes, Professor.
Yes, Professor.
Okay, so let's just start. Marginality of the marginal utility of marginal utility of L divided by marginal utility of Okay, so basically equal to the ratio of marginal utilities of Y and L. Alright, so the slope of the indifference curve is the ratio of the marginal utilities. My God, it doesn't let you go back. It's very weird. It doesn't anyway. So the ratio of marginal utilities of Y and L. There should be a space. I can't go back. Okay. So at the equilibrium, what happens? Right at equilibrium, so minus W by P equal to minus MU L MUL divided by MU Y. So I can cancel the minus sign. So W by P is equal to MUL by MUY. So we can write equal to MUL by W. MUL by W equal to MUY by P. Okay, so this means that for power spent on leisure, that's the same happiness as spent on consumption. Okay, so pay attention all these DUIs because I can't type in delta. There's no format like can't I can't insert equations, so I have to go by D. Okay, so pay attention. So we had our full income constraint, and we know that the slope of the full income constraint is minus W by P, right? And slope of the indifference curve is like delta Y. So this distance by this distance, so delta Y by delta L, which is like delta Y by delta L, and we are multiplying by like du and dividing by du, right? So basically we're multiplying by the same number and dividing by the multiplying and dividing by the same number, so nothing changes, right? So we are just manipulating du by dl, we're keeping this part, and then we are multiplying again by this the same amount dy by du, so nothing changes. See, dl d like dl by du by dy and dl times du. So it's the same thing, numerator and the denominator. And then what we did is like, we are keeping du by dl, and then we are multiplying by like, we are flipping this thing, right? So instead of dy by du, we are like saying 1 by du by dy. It's the same thing. So, but du by dl is how your utility changes when you change your leisure by 1 unit, which is basically marginal utility of leisure. And then 1 by like du by dl is basically saying that like what is du by dy. Du by dy is how much your utility changes when you change your consumption by 1 unit. So this part is marginal utility of y. By 1 by marginal utility of y is because, so basically divided by MUY. All right. So this is basically the marginal utilities of Y and L. At the equilibrium, the two slopes are equal. So basically, minus, because they are both of them are downward sloping, so there will be a minus sign in front of them, which you can cancel. So W by P should be equal to marginal utility of L divided by marginal utility of Y. If you cross multiply, right? So basically, it would be marginal utility of L divided by W equal to marginal utility of Y divided by P. So if you divide by W, that means it's a money number, right? It's a dollar amount. So per dollar spent on leisure, that means each hour you spent on leisure and the value associated with it. So each dollar you spent on leisure should get you the same utility as each dollar you spent on consumption commodities, right? If the two utilities are not equal, the two ratio, like marginal utilities are not equal. Let's say if you get more leisure per dollar, right? The more benefit from leisure per dollar spent than consumption, then you should actually start enjoying more leisure, right? And reduce consumption. But if you keep on doing that, remember there is a diminishing marginal utility. So if you keep on increasing leisure, the marginal utility of leisure will go down. And since you're on a budget constraint, if you reduce MUY, if you reduce consumption Y, then your marginal utility of Y will basically increase. So this side will basically go down and this side will increase and eventually they will be equal again. So they will reach back to equilibrium condition again. Okay, and then once you reach equilibrium, there is no need to change your behavior. So basically, this is saying that at this equilibrium, the two slopes are equal, meaning that per dollar spent on leisure gets the same happiness as per dollar spent on consumption. That's the equilibrium condition. Okay, all right. So let's go back to our note. Okay, so that's basically like, the optimal condition, and at the tangency point, we achieve whatever we wanted to do. That means we identify the optimal consumption amount and optimal leisure amount. And once we identify the optimal leisure amount from 0 to L, if this is my optimal leisure amount, then 0 to H, exactly like below this. So T minus L star is going to give me my H star, right? So this is going to be my optimal hours of work. So through this maximization process, I have identified my optimal level of consumption, optimal number of hours of work, and optimal number of hours of leisure time. Okay, so that was the task that we started off, like, to identify. Okay, so now this reservation wage, the definition of reservation wage, we have used it in many like circumstances, especially in game theory, but now you will understand what it actually means. So the absolute value, why? Because it's downward sloping, so we have to take the absolute value. The absolute value of the slope of the interference curve is a measure of the opportunity cost of time at this point, of course, right? Because it's going to give you how much consumption you have to sacrifice to get 1 hour of, like, leisure time. So 1 hour of time, the opportunity cost of that particular leisure time is given as the slope of the interference curve. Okay, so that's pretty straightforward. Um, the absolute value of the slope of the interference curve serves as a measure of the amount of income that is required to induce the worker to give up 1 hour of leisure time. The slope of the interference curve is the rate of substitution between consumption and leisure. Let me go up a little bit. So slope of the interference curve is the, like, trade-off between consumption and leisure. So how much, when you're over here, how much income will you give up to gain a little bit of leisure is indicated by the slope of the interference curve. Okay, when the interference curve is steep at this point, that means the large changes in income is required to induce the worker to basically 1 additional hour of work. So if you want this worker to, like, induce this worker to increase these hours of work by 1 hour, you have to give this person a lot of income, otherwise he will not work. Okay, so that means he to give up 1 hour of leisure. He is happy. If you give up 1 hour of leisure, then you have to uh, compensate this worker with a lot of income. When the indifference curve is very flat, right, then a small increase in income can induce an additional hour of work when the indifference curve is relatively flat. So when you are over here in this range, look at this, a little bit of income, right? If you sacrifice a little bit of income, the worker is happy to give up this amount of leisure. Okay, so this, if he gives us this amount of leisure to just to increase your income by a small tiny bit. Okay, so in the steeper part of the indifference curve, the worker has to be compensated by a lot of income if he has to give up 1 hour of leisure. In the flatter part of the indifference curve, the worker is happy to give up a lot of leisure for a little bit of income. Okay, so basically what it means is that when the indifference curves are relatively steep, in the steeper part of the indifference curve, the value of time in non-market activities is relatively high. So when it's very steep, right? So the leisure time is very expensive, right? So this 1 hour of leisure is equal to this amount of income. Okay. So that means like what? Like, your 1 hour of work is very valuable. All right, or 1 hour of leisure is very opportunity cost of 1 hour of leisure is very valuable. You have to give up that amount of income to sacrifice 1 hour of leisure. So leisure time is very expensive. When it's very flat, you are happy to sacrifice so much leisure for a little bit of income. So leisure is not as expensive, right? It's not as valuable in this flatter part of the indifference curve. Okay, so now comes the definition of, before going to the reservation, weight rate, we need to understand corner solution. If your indifference curves are very, very steep, right? So it will have this sort of a shape. So a corner solution occurs when the indifference curve is steeper than the budget constraint at a point corresponding to 0 hours of work. So let's just take this indifference curve. So the corner solution is over here. So this is your budget constraint, and the highest indifference curve is basically, touching at 3 hours of work. So basically all leisure and zero consumption. So this is a corner solution. You're just picking one corner. That means all or nothing, right? So this is basically all leisure and zero income. This point is called corner solution, right? So at this point, the consumer is consuming all leisure and zero composite commodity. Okay. Now pay attention. Okay, at this point, right, if you want to, this guy is all leisure and zero consumption. Given the shape of the indifference curve, this is this is the highest he can reach, and he wants to enjoy all leisure and zero consumption. If you want to induce him to work, right, you have to pay him a salary that is high enough. So look at this. In this situation, if the slope of the budget constraint, right, is basically if the slope of the indifference curve is bigger than the slope of the budget constraint, right? So look at this, the slope indifference curve is much steeper at this point. So if the slope of the indifference curve, like here, you can understand here better. So let's say this is my slope of the budget constraint, right? My budget constraint is over here, which is W minus W by P. And this is the slope of the indifference curve at 0 hours of work. So basically this is all leisure at this point. So we can see that if the slope of the budget constraint, right, is higher than the slope of the indifference curve, then the individual will work, right? See, because now you want to reach the highest possible indifference curve, but stay on the budget curve. So you can move to a higher indifference curve. You can have an indifference curve over here. So the individual will work, because still you can move to a higher indifference curve than U2. Look at this range, right? You can move to a higher indifference curve. So any indifference curve like this, right, will be tangents, and that means this individual will be working this much. Okay, so if the slope of the budget constraint is higher than the the slope of the indifference curve at 0 hours of work, that means the individual will actually work, right? But if it's the other way around, if the slope of the budget constraint is smaller or lower than the slope of the indifference curve at 0 hours of work, this means that the individual will not work at all. Okay, so this is called the reservation wage. So basically you need the wage rate that you need to induce this worker to work 1 hour of starting from zero. So basically this individual is working 0 hours of work, right? So to induce this worker to work 1 hour, that means give up 1 hour of leisure, the market wage rate has to be higher than the slope of the indifference curve at 0 hours of work. So the individual will only work if the slope of the budget constraint is higher than the slope of the indifference curve at 0 hours of work. Okay, so the slope of the indifference curve at 0 hours of work is basically your demarcation point. It says that okay, at this wage rate, right, or the slope of the indifference curve at this tangency point, right, the worker is enjoying all leisure and zero consumption. He's not working at all. Okay, so this is basically telling you that to induce the worker to work, to supply labor, you have to pay him a wage rate that is higher than this slope, right? So the slope of the budget line has to be, or the full income constraint has to be higher than this slope. Only then this worker will be working. And in this range, from this intersection point to T, you can see that this individual can reach a higher indifference curve, right? So this individual will be working. But in this situation, if this is the situation that the slope of the full income constraint is lower than the slope of the indifference curve, then this individual will not work because the individual has higher utility, because this, look at this tangency, right? As higher utility than anything he can achieve through this full income constraint. So in this type of a situation, this individual will not be working at all. Okay, does it make sense?
Yes, Professor.
Okay, so remember one thing, the corner solution is where basically the indifference curve is basically touching or intersecting the full income constraint at 0 hours of work. So all leisure and zero consumption. So this is called the corner solution. And the slope of the indifference curve at this point, right, at this point is called the reservation wage rate. To induce the worker to work 1 more hour of work, you have to have the full income constraint. The slope of the full income constraint has to be higher than the slope of the indifference curve at these 0 hours of work. Okay, so this is basically the summary of all of this. Okay, now we are going to introduce non-labor income to the model that we just studied little while ago. What is non-labor income? Non-labor income is some income that you do not have to work for. So if you earn some bequest from your grandmother, so you inherit some property, or you have a lot of stocks, and these stocks earn dividend, and it, lots of like the stocks price increases, right? So basically there is some gain from the stock market. You do not have to work for it. Your money is invested and the money gives you returns, right? So we call them earned income. So you're not earning them, right? You just basically receiving them, right? It's a part of your income, but you do not have to spend your hours of work on them. So let's just say this A is your total amount of non-labor income. So the time constraint doesn't change at all, but the good constraint changes. Now your total consumption expenditure on consumption, Y should be equal to your earnings, the amount you earn from the market by spending 8 hours of work, plus your unearned income or like non-labor income together should be equal to your expenditure on output. Okay, so basically your goods constraint changes. As a result, what happens, you can see that your budget constraint changes. It's the same thing. Now the vertical intercept becomes WT plus A by P. A is also a constant, like a parameter. So we can see that if you compare it with this situation, it's just that the slope remains the same, W by P, because that's the market determined rate of trade-off between consumption and leisure. So that doesn't change, but the vertical intercept rises by the amount of non-labor income, right? So basically it just shifts parallelly by the amount of A. So if you have higher and higher level of labor and non-labor income, your budget full income constraint is going to shift upward by this. So as if your non-labor income gets bigger and bigger and bigger, it's just going to shift parallelly, right? But remember, like there is no, this is just starting from here, right? There is a higher income, but the slope remains, so they're parallel, all of these lines. So that means the slopes are the same, right? The trade-off remains the same between Y and L, but the vertical intercept just increases. Now, if you see this, like, if you have like, non-labor income, you will see that your optimal equilibrium point will occur to the right of the previous equilibrium. The reason is A is just income, right? Pure income. So that means when you have higher income, you will basically consume more of both goods. Since leisure is a normal good, so you will consume more leisure. So it will be to the right of the the original equilibrium. So if your non-labor income keeps on increasing, your equilibrium will continue to be to the right. And you can see that in both the new equilibrium, right, both Y and both L is increasing because both of them are normal goods. So when you have higher income, you're increasing consumption of both of them. Okay, does it make sense? So this is pure income effect because there is no substitution. We are not changing the wage rate. We are just increasing income. As a result, both of these consumption and Y and L both are normal goods. So as a result, both of them, the consumption of both of them will increase. Okay, so we will have a pure income effect, and we are moving from to a point that will be always to the right of the original or initial equilibrium. Does it make sense, everyone?
Yes, Professor.
All right. I am not going to go into substitution effect and income effect today. Do you want me to go through this substitution and income effect? I think we had too much. So what I want you to do is, can you guys access it? Like, if I leave it in share, can you move and go up and down? I don't know whether you can do it. Can you do it?
Professor, you have to give all of us the access.
How do I do that? How do I? How do you do that? I don't know how to do it. You guys can draw, I can see that, but I don't see how advanced. Let me see if there is advanced. Music, no, there's a camera, second camera, that's not going to help us. This is not helping us. So participants, let me see if there is something. Allow exit entry, lock meeting, enable waiting room. So that's not going to happen. Help us either. Pause share, remote control, more. I don't think it's possible either. Yeah, you're right. Um, anyways, so does it allow you to scroll up and down right now, the document? Hello?
Professor, we are not watching the document at all.
The document has vanished?
No, Professor.
All right, now can you see if you can scroll up and down?
No, Professor.
So I think it's not possible. Okay, I'm sorry. All right, so that's not going to happen. So what we can do is we can take a 5-minute break and come back and do substitution of effect and income effect. I'm just going to go over and then I will repeat again like in next class. Okay, I know it's a lot, but like we will repeat again in next class. Or like let me just go through it and then I will let you go early and then I will repeat it again in Sunday. All right, how about that? Okay. So let's say like this is like W0 T by P is our like and T. So this like the first line where A is the equilibrium is our initial equilibrium, right? And there is a wage increase. Wage rate rises from W to W0 to W prime. So if wage rate rises, what happens? The slope increases, right? But then T doesn't change. So what will happen? There's the full income constraint because with a higher wage rate, you have higher income. So it's going to rotate this way. So then this line becomes your new full income constraint. Okay. Now, because it's a wage increase, so two things will be happening. With higher wage rate, what will happen? Your leisure becomes like very costly, right? With higher wage rate, you want to work more. Your opportunity cost of leisure becomes costly, so you actually increase your hours of work. Okay, so what happens? Like you basically increase your hours of work. That is called substitution effect. Holding utility at the same level as before. Okay, so what are we doing? Remember, like this is the new slope. So the new the W prime by T. So this is the new like wage rate. So this is then you bring a parallel to the old indifference curve. So U0 is your initial indifference curve, right? That is the tangency was at A. So what you do is you bring your like this new budget constraint parallelly down until it becomes tangent to your old indifference curve. Okay, so if this is the case, we can see that the new equilibrium happens or the tangency happens with the new budget constraint, the same slope, right? So this line and this line has the same slope, happens at B with the old indifference curve. So you move from A to B. That means you're reducing leisure. Remember, leisure is measured rightward. So if you're going leftwards. So that means you're actually increasing your hours of work. Okay, so you're increasing your hours of work and you're increasing your consumption also a little bit. Okay, because if you work more, you're going to have more consumption. Okay, so you move from A to B is basically substitution effect, keeping your utility same as before. But actually your budget constraint or full income constraint has moved to this, like, this one. So your actual in tangency, the final tangency occurs at C. So the move to B to C is basically, look, the slopes are the same. This slope and this slope are the same. So the price ratios are the same, only you are moving to a higher indifference curve. And the move to a higher indifference curve means higher income. So the move from B to C is basically income effect. Okay, holding the price ratios constant. So this is at the new price and this is also at the new price. So the move from B to C is income effect and the move from A to B is substitution effect. So what is actually happened? Eventually you are moving from A to C. So this is what we see whenever there's a slope, like change, or the W changes. This is actually happening. We are moving from A to C with the wage rate increase from W to W prime. But we are going to break this change. So this move from A to C is the total effect. We are going to break it into substitution effect and consumption, substitution effect and income effect. Substitution effect says basically how you change your combination of leisure and consumption holding utility constant, right? And how, because the price ratios have changed, how will you select in the new price ratio? With the new price ratio, how will you select your labor and leisure and consumption at the new price ratio, keeping utility constant? To do this, you have to bring the new slope, right, this line parallelly downwards, right, till it becomes tangent to the old indifference curve. And we can see that it becomes tangent to the old indifference curve at point B. The slope of this line is exactly equal to the slope of this line. So the move from A to B is then by definition substitution effect. Okay. Now compare B and C. We can see that the slope of this line and the slope of this income constant, they are the same. So basically this is reflecting the new price ratio, W prime by P. Okay. So the slopes are the same, but you are moving from B to C. So you're moving from U0 to U prime. So you're moving to a higher indifference curve, and higher indifference curves always indicates higher income. So move from B to C is income effect. So what does the definition of income effect? Income effect is saying that holding the prices constant, right? Income effect is reflected by move to a higher indifference point or a higher indifference curve. Okay? So the move from B to C is income effect. So you move from substitution effect is going from this way, A to B, and income effect is moving from B to C. So we can see that, like, the actual move is very tiny from A to C. All right. So part of the substitution effect is dominated by income effect. So eventually we see that because income effect dominates, and that means like, you are going to consume more of both leisure and consumption, because income effect means, like, when you have higher income, both leisure and consumption are normal goods, so you are going to increase them. So you're increasing leisure from this point to this point, you're increasing leisure and you're increasing consumption, both of them, right? But substitution actually saying that you actually increase leisure a lot, but because of damping effect of the substitution effect, right, we can see that it's actually increasing by a little bit. Okay, so with higher income, you are consuming more leisure and more consumption eventually at C. If you break it down between A and substitution effect and income effect, we see that both of them are, substitution effect and income effect are working in opposite direction, and the income effect dominates because income effect is bigger than substitution effect. So that means when income effect dominates, that means we are going to enjoy more leisure and more consumption. Okay, does it make sense? All right. I know I'm going to a little bit fast, like, but let me finish. I will repeat it again. This is like, another situation where actually the substitution effect dominates. So if this is a situation, again, your initial equilibrium was at A and the wage rate rises. So because the wage rate rises, the slope increase. So you rotate this way, this becomes your new budget constraint, right? And your tangency occurs into a higher indifference curve at point C. Okay. To find the substitution effect, you have to bring this new budget, this new full income constraint parallelly downwards until it becomes tangent to the old indifference curve at point B. So the move from point A to point B. So this is basically substitution effect. And move from B to C is your income effect. Only this much. So we can, in this situation, we see that substitution effect dominates, right, at C. So since substitution effect dominates, what happens? We see that, like, you're actually increasing, going from A to C this way. That means you're actually increasing hours of work. And when you increase hours of work, that means you have more income. And when you have more income, that means you have more consumption. So this is consistent. Okay, so what is happening? What is the difference between these two graphs? In this one, income effect dominates, and in this one, the bottom one, substitution effect dominates. Okay, all right. So I am going to let me see if it allows me to copy this. I don't think it will allow me to copy this to the whiteboard, but I want you to draw it on your own. So, and that's your task, and then I'll let you go. So you draw, like, the full income constraint with a slope of W by P. And then think that the wage rate increases. So rotate it like this, right? And then what you do is you have your A with the tangency of one indifference curve, okay? To have your substitution effect dominating income effect, remember your new equilibrium has to be in between A and B. To have income effect dominate substitution effect, you have to have your C to the right of A. Okay, C cannot be to the, like, left of B, because that means that, like, both of them are working in the same direction. Okay, the problem with that is that, like, if your substitution and income effect are, like, working in the same direction, that means that, like, higher wage rate is going to increase your, like, leisure, and no, when that means, like, substitution effect, you're increasing leisure, and income effect is also asking you to reduce leisure, which is counterintuitive, because income effect means you have to increase leisure, not reduce leisure. Okay, so it cannot, any point to the left of B cannot happen. So it has to be, like, in between, or it can be on top of, like, B, exactly on top of B. That means income effect and substitution effect cancel each other. It can be in between A and B. That means substitution effect will dominate income effect. It can be to the right of A. That means income effect dominates substitution effect. But for now, just focus on the 2 points, that if you have your final equilibrium C, this point is to the right of A, then you will see that your income effect dominates. If C is in between A and B, if you put C over here, like the graph over here, then you will see that substitution effect dominates. Okay, so I want you to, I'm going to end the class right now. I want you to practice this. So I want you to first put C to the right of A, and then put C in between A and B. If you can draw these two graphs and figure out, like, income effects and sub effects, that's, like, excellent. Okay, if not, what I will do is I will draw all the scenarios, and I will send you the pictures of my drawing. Okay, So let's leave for now. And but you guys stay and you guys try to draw the two graphs in your own notebook. Okay. So draw this, right? You know, that C is the new equilibrium is to the right of A, and then you draw the second one when C is in between A and B. And you understand B. B is that this line, this new full income constraint, this line drawn parallelly downward until it becomes tangent to the indifference curve U0. And it has to be to the left of B. Why? Because wage rate has increased. So when wage rate increases, substitution effect means always you're going to work more because opportunity cost of your leisure is really high, right? Each hour you spend at home, you're sacrificing a bigger number, a bigger salary. So obviously you will reduce leisure and increase work. So like, you know, when you bring it down with the higher slope of W prime by T times T by P, it has to be to the left of A. All right. So can you guys start drawing in your copy? Okay. So you practice these two, and I will send you my drawings. Like not today, I'm just exhausted right by now. I will send it to you. Try to send it to you by tomorrow, and I will upload a bunch of practice problems. And we are meeting Thursday. Okay, the Thursday at 8:30. So we will finish this chapter, solve some problems Thursday, and then we will have our exam on Sunday. Okay, this is our plan.
Professor,
Yes.
could you upload the notes as well?
Yes, the notes are there, no? If not, then I will upload them. Okay.
No, Professor.
Okay, I'll upload the notes.
Professor, will the exam be on Sunday?
The exam will be on, depending on how it goes on Thursday. If we can, like, you know, if you're comfortable, we'll have it on Sunday. Otherwise, we'll have it on Tuesday. Okay. So let's meet Thursday and see how it goes.
Okay, Professor. Professor, will you be sharing the recording tonight? Is it possible?
Yes, yes, I will share the recording tonight.
Thank you, Professor.
Okay. All right. So you guys carry on. You guys start, like, you know, practicing this, and I'm leaving. I'm going to go and have some tea. Okay. We didn't take a 10-minute break in the middle. We have 10 minutes left. So I'm ending the class. Okay. You guys take care and have a safe, like, you know, the remainder of the day. All right. Take care. Bye.
Bye, Professor.